Imagine this. 2,000 years ago, the Romans built cities, bridges, and roads that are so incredibly durable, they still stand today. You can walk on them, touch them, see them with your own eyes. But here's the strange part. The part that keeps modern engineers and scientists up at night. We still can't fully explain how they did it. Think about that for a moment. We have supercomputers, advanced materials science, and satellites. Yet we're still scratching our heads over ancient techniques. What secret technology did the Romans know that we've somehow lost to time? What forgotten genius allowed them to build an empire of stone and mortar that defies the ages? The answer is far more incredible than you might think, and it's a story of innovation that was literally centuries ahead of its time. It all starts with something we think we know so well, something we use every single day in our modern world: concrete. But Roman concrete wasn't like our concrete. Ours cracks, crumbles, and needs replacement within a few decades, maybe a century if it's lucky. Roman concrete, on the other hand, gets stronger with time. It doesn't just last longer, it actually heals itself. For years, this was a complete mystery. How could a man-made material repair its own damage? Recently, scientists made a breakthrough. They analyzed samples from ancient Roman harbors and walls and found tiny white chunks, which they called limeclasts. For a long time, these were thought to be a sign of sloppy mixing. But the truth is the opposite. They were intentional. These limeclasts, when exposed to water seeping into a crack, dissolve and recrystallize, effectively filling the gap and sealing the structure. It's a self-healing mechanism built right into the material. The secret ingredient? Volcanic ash, or pozzolana. This special ash, abundant in the regions around Rome, reacted with salt water and lime to create a uniquely stable and non-corroding binder. This meant their piers and seawalls, constantly battered by the ocean, became more solid over the centuries. It's an incredible feat of chemistry and engineering that we are only now beginning to replicate. So, let me ask you, would you trust a 2,000-year-old bridge more than a modern one? Let me know what you think in the comments below. But self-healing concrete was just one piece of the puzzle. The Romans applied this level of genius to everything they built. Take their aqueducts, the lifeblood of their cities. These magnificent structures carried fresh water across hundreds of kilometers, snaking through mountains and across valleys. And here's the mind-bending part. They did it with almost no pumps. The entire system was gravity-fed. To achieve this, Roman engineers had to calculate a precise, continuous, and incredibly gentle slope over immense distances. We're talking a gradient of just a few centimeters for every 100 meters. A slight miscalculation, and the water would either stop flowing or move too fast and erode the channel. Then there are the roads. The famous saying, "all roads lead to Rome," isn't just a metaphor. They built over 80,000 kilometers of paved roads, creating a network that connected the vast empire. But these weren't just simple dirt paths. Roman roads were complex, multi-layered constructions. They were dug deep, filled with gravel and stone, and then paved with fitted flagstones. Crucially, they were built with a slight curve, or camber, so that rainwater would run off into drains on the side, preventing flooding and erosion. This is the same principle we use today, but they perfected it 2 millennia ago. And what about public spaces? The Colosseum is a masterpiece of crowd control. It could hold over 50,000 spectators, and yet its system of entrances, staircases, and corridors, called vomitoria, was so efficient that the entire arena could be emptied in just a few minutes. Modern stadium designers still study its layout. But how could they measure everything so precisely? The gradients of aqueducts, the angles of roads, the complex geometry of an amphitheater, all without lasers, computers, or modern surveying equipment. They relied on simple but ingenious tools like the groma for right angles, the chorobates for leveling, and the dioptra for measuring angles. Their genius wasn't in their tools, but in their mastery of mathematics and their unwavering commitment to precision. So, if the Romans were this advanced, what happened? Why did this incredible knowledge seemingly vanish for 1,000 years? The answer lies in the turbulent period that followed the fall of the Western Roman Empire, often called the Dark Ages. As the empire fractured, society destabilized. Constant warfare, political chaos, and economic collapse meant that large-scale public works were no longer a priority. The sophisticated systems of education and apprenticeship that passed down this specialized knowledge from one generation of engineers to the next simply broke down. Many of the detailed manuals, blueprints, and architectural treatises were lost forever. Libraries, like the Great Library of Alexandria, burned, taking with them countless scrolls of accumulated knowledge. The specific formulas for their miraculous concrete, the precise surveying techniques for aqueducts, much of it was lost or became fragmented, turning into closely guarded trade secrets that eventually died out with their keepers. For centuries, humanity had to essentially start from scratch, slowly rediscovering the principles of engineering that the Romans had mastered. But today, a new chapter is unfolding. Archaeologists, scientists, and engineers are working together, reverse engineering Roman formulas from ancient samples. They are studying the ruins not just as historical artifacts, but as blueprints frozen in time. Scientists are now creating modern versions of Roman concrete, hoping to build more sustainable infrastructure for our future. We are literally digging through the rubble of the past to rebuild a better future. It makes you wonder, what if the Romans had never fallen? How advanced would our world be right now? Share your thoughts on that. From self-healing concrete that defies decay to flawless aqueducts that tamed nature, Roman engineering wasn't a product of luck. It was the result of relentless innovation, a brilliant fusion of science, mathematics, and pragmatic design that was truly centuries ahead of its time. They weren't just building structures, they were building a legacy. They understood that the strength of an empire wasn't just in its armies, but in its infrastructure, in the roads that connected its people, the water that sustained its cities, and the monuments that proclaimed its glory. They engineered systems designed to outlast not just a lifetime, but entire empires. And as we continue to decode their methods and marvel at their accomplishments, one thing becomes clear. We are still learning from the masters. We are rediscovering a form of genius that never truly died, it was just waiting for us to find it again. If you love uncovering ancient secrets and exploring the lost technologies of the past, make sure you hit that subscribe button and turn on notifications. We're rebuilding lost history, one incredible fact at a time. Thanks for watching, and we'll see you in the next one.